A number of questions came in on the online platform. We are joined by Maarten Pothaar, marine engineering student at the university currently. He will have a number of questions as well in a moment. The first question is, and you sort of addressed it already, but please elaborate a bit more. Do you have any data on the waste that is collected? So is there a type of plastic that is more prominent? And can you see also perhaps a temporal aspect? So is there now more PPE turning up than before or so?
Yeah, I'm not aware of temporal trends in the plastic composition. Of course, what we do see in temporal trends is the amount of plastic increasing. So since I believe 1997, the first expeditions were conducted in the North Pacific, and now we see roughly a tenfold increase in the amount of plastic. So there's clear trends going upward, but in terms of the precise composition, we haven't seen any big changes. Okay. As Arjen, you said, there is a lot of fishing gear in the Great Pacific Garbage Patch. There's probably a bias there because the stuff that's coming from coastlines is usually from a slightly different composition, and so basically for stuff to be able to persist for a long time in the middle of the ocean, it needs to be usually thick-walled. If we look at this stuff, it's all quite robust material. So if you think of plastic bags, they probably disintegrate too fast to really make the 7-year journey all the way to the center of the patch. So that's one thing. And then there's also the fact that stuff that's released near the coastline has a very high probability of beaching. So within a year, our models predict 97% of the plastic that has left rivers will be back on the coastline. So the chance of coastal, sort of land-based waste to actually make its way to the middle of the ocean is pretty small. Well, if you have a fishing net that usually gets lost in the ocean, you have, the chance is much higher. So you have this selection effect, this observation bias. Mm-hmm. And so that's why we think we see a lot of fishing gear. I mean, the good news is fishing nets are actually the highest quality material we see in the patch. So for the recycling perspective, that's kind of an advantage, actually. Okay,
that's interesting. And perhaps also a bit related to then finding a lot of fishing gear, there's also some concerns, and you also addressed that already in your presentation, about interaction with marine life, of course. Is there any interaction with marine life? What are you doing to mitigate that in the retention system, I mean?
Yeah, so as said, it's hard to say there will be no interaction, right? It's really about making sure that we make informed choices based on the best available data. So I think the core principles stand that with the environmental impact assessments that we've done, we see a very low to negligible risk profile. And secondly, that we see of course, the risk profile to be of temporary nature. It's just a few years, this cleanup, while of course the benefits will last for decades or centuries, or otherwise said, the counterfactual of leaving the plastic out there, that will continue to do harm for decades or centuries. So I think putting things into perspective, so looking at the expected value perspective rather than sort of the gross impact, I think then the profile looks really good. But again, there are some knowledge gaps for particular species, for example. So hopefully, we'll be able to study these, get enough data, and indeed conclude that there is no environmental risk.
Yeah, I understand. And I guess you won't be putting any popcorn in the Great Pacific Garbage Patch.
No popcorn, no.
No. We'll fish for the real stuff there.
Yes, no need. Yeah.
Very good. There's also an interesting question on, now that you are using active propulsion, what data do you record in the onboard systems? And have you considered collecting more or other data that could perhaps also be sold? So in that sense, also be used as a product of your activities.
Yeah, so I can take this one.
So on the vessel, we'll be recording all that's related to the mid-ocean conditions, so the wave field, the wind, the speed through water of the vessels, also the water current. We'll have remote sensing that will be doing this type of measurements. We'll also be doing, let's say, a big chunk on the environmental monitoring. So it's also interesting for the geochemicals out there, I guess. And obviously, I mean, once we'll be able to have a swarm of cleanup systems also measuring some information, then obviously we'll also improve the models that are out there and will be available to the global public, I would say.
And on the retention system also we measure positions and motions, so we know the shape and the behavior in the waves there. And indeed, as you showed, Boyan, we have that camera skate in the retention zone where we can see, well, position, but also we can see what's with the cameras, what's happening underneath that. Yeah,
and then I think on the commercialization question, yeah, we believe a lot in open access data. So even though there may be some value in it, I think ultimately there is greater value on a societal level to just share data openly. So yeah, so we don't have any intent to move away from that principle.
Okay, thank you. That's very beautiful, and perhaps someone else can do something beautiful with that data. Then that would be very good.
Yeah, and then by the way, there's also an ethical component. I think that the fact that we are funded by the public, basically, so by donors, etc. I think they, have the right to see what we do with the funding, right? So.
Yeah, very good. Yeah, that's also why we have to publish open access, or we like to publish open access at the university as well. There's also, this is a rather interesting question, a bit dreamy perhaps, but suppose you had no budget or regulatory limitations. How would you design the system then and its operation? Would it be pretty much the same, or?
I think it would be quite the same indeed, yeah. I think what we're looking for is to get to the most efficient system and then the best performance in that sense. And that's not only relating to budget, but also to, well, as Boyan explained, fuel consumption, but also just the capturing performance. So I think we would end up with the same system basically, and I don't think there would be much change without those restrictions. Maybe there is a regulatory limit sort of on the span, so maybe the span would be a bit bigger. But again, then there's other limits like wave following and the maximum tension that we can have in the system. Yeah. So I don't think it would be much different. Yeah.
So there might be a limit or just a good optimization at that 1800 meter span that you are now aiming for.
Yeah, I don't think it's certainly not far from the optimum. No. Yeah.
But that is system 3. Why first system 2? Why not go immediately full scale?
Well, we have an iterative approach in our concept development. So we start with smaller testing and then iteratively work towards a final system design. So this is one step there. And it sort of is a balance in between the previous system that we have and the full-scale one, where we want to, of course, put our system to a good test. Yep. And this is definitely big enough to do that. But it's not the full size yet, because then there's of course higher cost to do that. There is more risk in doing so. It's harder to manage. So we think it's a very good stepping stone towards system number 3. That should be sort of the blueprint of the whole fleet and the final size.
Okay. Thank you. I actually see new questions still coming in. Very good, ladies and gentlemen. Please keep doing so. One of these latest questions that came in is perhaps a question for Bruno. You have used lots of modeling in your designs and efficiency estimates. So how well do you think these models predict the performance, and is there any uncertainty in it?
So actually there are two things. There are the models that are being used to look at tens of years of operations, and those in a way they've been reanalyzed. So that means that they've been taking like all the available measurements to make the model as accurate as possible. So those models being able to replicate the future, that for sure it's not going to happen, but at least you know that if the cleanup would have happened 10 years ago, then this is the efficiency that we would be reaching. And then there is the other aspect, is the forecast models, so the models that are being updated like every day. And for those, we're actually taking great steps to actually gather as much measurements as possible to make those models as realistic as possible. But yeah, we need to keep in mind that models are being used every day. You know, when you're watching your forecast, those are models, and even though they can have like a few hours delay and things like that, but usually they kind of well represent reality. So that's it's in the type of realm that we are working on, even though let's say the plastic forecast is not yet a product that you can find on your everyday night show, but maybe one day it will be.
And also, it's also one of the objectives of the test. We will get, of course, quite a lot of new data there. And that part of that we will use to validate our models and to see how accurate the forecasts are and how we can improve that. And there we get that self-learning part of the system. The longer we're out there, the better the models will be, and the better we can target those hotspots.
Yeah, very good. There's also an important question when you are out there. You've shown a couple of very nice movies, and actually the oceans and the seas seemed rather calm then, but of course to sailors it is well known that well, that's not the typical situation that you will find offshore. So how will your system deal with rough ocean conditions?
We have designed the system to withstand quite rough conditions, of course. We have the data from earlier systems that we can use, and we have the data from that North Sea test, so we have quite a good estimate of the loads we can expect within that retention system. And then we designed it, of course, with a good safety factor as well to be sure that it can manage that. But also now that we have those crewed vessels, we have other options there, and that is to target those plastic hotspots, but also to avoid bad weather. And luckily, the two are expected to go hand in hand. So basically, where the weather is nice, there's more plastic expected.
That would be
so
good.
There's two reasons to go there.
Yep.
And if we would end up in very bad conditions or a very bad storm is coming or whatever, then we can recover the system and ride out the storm or put it in a standby mode while it's still in the water. That depends a little bit on how bad the situation would be or how severe the storm would be. Mm-hmm. And then we can redeploy it afterwards and continue cleaning then.
Okay.
So the HS, the maximum that we use for operation modes are like 5 meters?
Yeah, somewhere in the range of 5 meters we expect that the system can remain operational. And then above that we go either in that survival mode or we completely recover it and then redeploy it afterwards.
Yeah.
And, uptime wise that's over 90% of time.
And maybe
that we're in operation.
Maybe one thing that you can also mention is that now that we have an active system and we see like a big storm approaching, then we can also try to deviate from our trajectory.
Yeah. So you do need good weather forecast as well.
Indeed.
Very good, very good.
I think the peak loads, we expect them during handling, right? During the recovery of the retention zone.
Yeah, depending on the part of the system, but indeed,
Especially with the larger system, it will be very large, so there might also be some type of interaction with other vessels. What types of interaction do you expect when operating at full scale, and how might that impact the cleanup of the vessels and the activities of yourselves?
We don't expect a lot because it's a relatively quiet area in the ocean. Yeah. In Dutch, it's called the quiet ocean for a reason, not for that reason. But we don't expect a lot of vessels to pass by. It's not a very busy shipping lane or something like that. No,
shipping lanes are.
But in the earlier missions, we did see other vessels, and there will be a notice to mariners, so it's known in that area that we are operating there, and the crews on board the other vessels should know. If not, the crews on our vessels can contact them. Yep. And if that's not successful, then we can change course and sail around. But we don't really expect an impact on the cleanup performance there because it's very rare, and we shouldn't have to change course.
Okay. I'm just looking at, there's one question that I don't immediately get, so I'm sorry, I'm going to skip that one. Yeah, this is also a very good question, very interesting. After proving the system, let's hope that Jenny will do very well. After proving the system in the Great Pacific Garbage Patch, will you move immediately to other gyres, and if so, which might be next? When do you think this might be? There was already a planning, of course, but
Yeah, so we expect to start on the research side with the other 4 patches next year. So we're now looking into mapping the Indian Ocean garbage patch. Firstly, because we think, considering there's quite some fishing there, quite some river sources on that ocean basin, it might be the one that makes it's like the second most polluted. So and there's also the biggest uncertainty as to where exactly the patch is and how its composition is. So I think from a research perspective, we would then start looking into that one, hopefully next year. And and then in terms of deployment, we would first want to have a full fleet out in the North Pacific before we would then start building other fleets. So I think it all depends on how quickly we can ramp up, which I think will again be largely dependent on available resources. So, it should be pretty quickly after the North Pacific fleet is out there.
Yep. Okay. You already hint towards the $1 million question, I suppose. Who's going to pay for all of this?
It's more than $1 million, actually. So, I mean, the precise answer we don't know yet. I think that's to be absolutely fair. I think there is an obvious business case because, yes, it's going to cost real money, but at the same time, the amount of money that it costs right now, again, the counterfactual is just way more. I mean, this probably has an ROI greater than most infrastructure projects for countries, right? So I think it makes sense to do. But and then the question is, who pays the bill? I mean, there is of course a case for governments to be involved, especially the governments sort of near these ocean garbage patches, who are directly economically impacted by it. But then there's also, of course, cases to be made with when it comes to individuals, corporations, and I think another thing that we're trying to do is, of course, to one hand is covering the cost, the other hand is reducing the amount of money that you need by, on one hand, looking in sort of in-kind partnerships, right, where you can imagine, of course, it would be great if, for example, the vessels we could use at a sort of a heavily discounted price like we do now, or even more than that would be even greater. And of course, the other thing is that we'll try to monetize the plastic, where nobody knows exactly how much euro per ton we can get when we valorize that. But I think that the story component of the material, there is quite some value to it, as we've seen with the sunglasses. So if we can scale that, I think it could be a significant contribution as well. Yeah, let's hope a good or a number of good partners come and join you in that respect. Very good. I guess again a bit more to the technical side. A question of you've spent a lot of time of designing the system and especially the retention zone, I can imagine. Could that concept of the retention zone be applied to other environments as well? Could currents and tides be used to help collect plastics drifting through a wind farm, offshore wind farm, for example?
Yeah, I think basically that concept would work whenever there's plastics. So it should be in a plastic dense area.
Density.
Yep. So density, indeed. It's basically those 4 parameters, right? So it's speed. You need to create a speed difference. So that could be currents or tides or any source of speed difference there. So theoretically, yes, I think so. But what we do see is that really the higher plastic density areas are those gyres in the middle of the ocean without wind farms and other infrastructure. So that's why we're taking this approach.
Okay.
Yeah, so when you think about the density of plastic, if you take the whole journey from land to ocean garbage patch, basically the density of plastic gradually increases towards river mouths, and then once it's left the river mouth, then it's you get this sharp decrease where it just becomes very, low density, and then it again starts to pick up at the edge of the patch. So ultimately where it makes sense to clean is where the density is highest. Either if you want to address the source, go as much as possible to the mouth, or if you want to address the legacy, the stock, then you want to be in the ocean garbage patch. In between, the plastic will either reach a coastline or a garbage patch anyway. So, and because the density is so low, it probably doesn't make so much sense to go there.
Okay, thank you. What is influencing the density of the plastic pollution as well is, of course, the size of the individual plastic pieces. So there's a question on will this system be able to tackle all sizes of plastic in the patches?
Well, we target everything from 10 millimeters and up, with the reason that the really small particles are a way bigger challenge to do. We did see that System 1B captured the smaller pieces as well. So that's something that we're going to keep an eye on for System 2 as well, of course, and we hope to be able to get those smaller pieces too. But there's quite some technical challenges to specifically target them. And with targeting everything above 10 millimeters, mass-wise, we have almost the whole mass of the garbage patch. So that's the reason for taking that approach. So almost the full range.
And don't forget, of course, basically the plastic's larger than the microplastic threshold. Of course, the microplastics of the future. One crate of plastic, one large object can turn into almost a million pieces of microplastic, right? So it's, I think targeting, especially because the mass is so heavily skewed towards the bigger objects, I think that it's the highest urgency to take out anyway.
Okay, very good. There's a couple of questions left, but I also like to give Maarten the floor because he actually has also a personal question for the ocean cleanup.
Yeah, well, thank you. You have mentioned using USVs as an alternative way for the propulsion instead of regular ships. When do you expect you'll be able to use these? And can I design one of those for my graduation?
And indeed, as you said, Boyan, in the past year, we've been looking into those USVs to use them as the propulsion units. USVs are a sort of proven technology. They're being used, but for quite different purposes. So what we found there is that they're generally not used to tow something. They're mostly for measurement. And also the endurance is an issue there. We need them to be out there for quite a long time, and that's not what they're designed for yet. And there's some other challenges as well. So what we want to do is further look into that and see if we can bridge the gaps there, and then hopefully use them for future systems. And yes, we would definitely welcome bright students to dive into that and help us design the USVs and to bridge the gaps.
Yeah, I think in general, right, we're always looking for smart and perseverant people to join the team, right? Not just students, but of course we have internships, but also jobs basically at any level. So for those interested in that, at theoceancleanup.com, there's a big list of vacancies now, and it gets regularly updated. So do check that out if you're interested.
Okay, well then also another question for you. As I believe the ocean cleanup was an idea of a school project of you. And we students do projects all the time. And do you have any tips to start up such a successful company or startup?
Yeah, it's hard to remember. But like 8 years ago, I was a student here, and stuff happened.
Life happens.
Yeah. Well, it's a very broad question. I think usually it's important to just start. I mean, I didn't know whether it would work, but thought it was worth trying. So so probably those are probably the two most important things. Just start and choose something that's worth working on, even if it doesn't work out, because the odds are against you when you start something like this. So I think that's important. And then also I think most things fail because people give up too quickly, right? So mean, if we look at the past 8 years, it's when we went through all these concepts and all the things that didn't work. I mean, every single time, like, it would be completely rational to say, like, okay, forget it. We tried, didn't work. So just looking beyond that and just keep looking for tiny holes and or like a string you can pull, and I think that's super important. So, but again, you want to do that on problems that really matter, because otherwise you can spend quite a few years on something that may not matter ultimately. So, yeah.
Perseverance. Perseverance as a factor of success. Yes. Very good. Ladies and gentlemen, I think by now we have come to the end of this session. I'd like to very much thank Boyan, Arjen and Bruno again for this very nice presentation. I wish you very good luck this coming summer and all the years ahead with System 3 and System 15 and etc.
Thanks.
Thank you.
Good luck. And thank you all for joining. And if there are any questions remaining, please post them via the website to the Ocean Cleanup directly. Thank you and goodbye.